Good evening, beautiful people. Happy New Year, happy 2023. Okay, so this is gonna be fun. It's gonna be late. It's gonna be challenging. It's gonna be hard, but we are gonna make it. Okay, so you are upon. So this I was going to grade 12 and official matriculant. Okay, so I'll be doing both grade 12 and 11 stuff. Okay, let's continue. So today I just want us to focus on Doppler effect. The reason why I'm starting with this topic, I know it's not a term one topic or something, but it's a short topic that I can just do it now and just finish within maybe I can just finish it within two by making 3 or 2 videos. Okay, so now let's get on with the work. So Doppler effect. So Doppler effect, it is about waves, it is about the sounds, about the source, about everything, but we are gonna learn as we are gonna continue in this video. Okay, so first thing first, what is the Doppler effect? Okay, so the Doppler effect, it is the apparent change in frequency. Okay, we wait there. What is frequency? Frequency, it is the vibrations per second. Okay, vibration that was there per second. Okay, then the apparent change in frequency of the sound detected by the listener. So let's read there. Okay, so the listener is someone who hears a thing or something that can hear another thing. Okay, so this listener is detecting the sound. Okay, so let's continue the definition. Because the source and the listener have different velocities relative to the medium. Guys, I think I bought a fake marker here. I have to buy another one of sound. I just needed a new one immediately, so I just had to get a new one, so I had no choice. Propagation. Okay, so let's now discuss the definition. Doppler effect. Okay, the Doppler effect, it is the apparent change in frequency of the sound detected because of the sound detected by the listener, because the source and the listener have different velocities relative to the medium of the sound propagation. Okay, so what comes in, something must come into your mind when you're now talking about the source. Something must come into your mind when you're talking about the sound. Something must come into your mind when you're talking about the listener. Okay, so let me explain. So Doppler effect, it is the apparent change in frequency. Frequency is the vibrations per second of the sound detected by the listener. So let's make an example. We have a stationary man standing there by the corner. Stationary means there's no acceleration, and then there's an ambulance there. Okay, that is also in a stationary, like in a stationary, like it is stationary. It is not going anywhere, and it is busy making that siren. What. So the sound that will be detected by the listener will be the same. The frequency there will be the same, because both things are on stationary. But if it happens the ambulance goes towards the man, the frequency will do what? Will increase, because it is the more the man will listen to the sound or the siren of the ambulance, because the more it comes towards him, it is the more there will be too much loudness, okay? And then if it passes him, it's gonna be too much loudness. And if it goes away from him, what will happen to the frequency? The frequency will decrease, because now the siren is now away from the man. He can't hear the siren just like when he heard it when it was coming towards him. So what we are talking about there, it is the frequency, okay? So there's another thing I will mention. It is the wavelength. So the more, let me write it down, you have to know it. It is the proportionality between the frequency and the wavelength. So the more we have them, if the frequency increase, then the wavelength decrease. This is lambda. It stands for wavelength. So if the frequency increase, the wavelength decrease. What is the wavelength? The wavelength, it is the distance between two phases that are the distance between 2 points that are in phase, okay? So and it will be the between the man and the ambulance. So that's how it is. Yeah, it is because of the proportionality there, okay? So since I have explained, so let's continue. Because the source and the listener have different velocities. Velocity is the movement or the acceleration. So since they said because the source and the listener have different velocities, listen, I said if it happens with the stationary man and the if it happens with the man is still standing there, is stationary, and the ambulance start moving and goes towards him or away from him, now the ambulance is now in motion. Now the velocities are different, because initially the velocities were 0 0, for 0 for the listener, 0 for the source, but now the source, which is the ambulance, is now moving at a certain acceleration. So the what do you call the velocity of the ambulance or the source will not what will increase, because it is no longer stationary, it is now in motion, okay? So that's why they are saying because the source and the listener have different velocities relative to the medium of sound propagation, which is what I'm talking about, towards and away, okay? So yeah, I'll be doing more. If I find something that I've missed, I will do it. I will and give it to you guys. So let's continue. Frequency determines the loudness or the pitch, okay? So frequency determines the pitch or the loudness, okay? Another thing that you have to know, the loudness is determined by the frequency. That's why I'm saying the more the ambulance comes towards to the man, they will be too loud, like the siren will be too loud. That's why they are saying loudness is determined by frequency. So now let's go to the wave equation. The wave equation. Okay, so now let's start. The wave equation, it is V is equals to F times lambda. So the V, it is the what? The velocity, okay, which is measured in meters per second. And then we have the F, which is the what? The frequency. I said the frequency is the vibrations, number of vibrations per second. So frequency, it is measured in hertz. And then we have the lambda there, which is the wavelength. Wavelength, it is the distance between 2 points that are in phase, which is measured in meters because it is the distance, okay? So let's now go back here. So this is the wave equation, okay? So I'll do an example after this. So now, since you have the wave equation, let me go to the Doppler equation. So the Doppler equation, it is like this. The FL, which is the frequency of the listener, it is equals to, open bracket, V velocity plus minus velocity of the listener over velocity plus minus velocity of the source, close bracket, times velocity of the source. The reason why there's a plus and a minus, it is because of there is a situation whereby the source will come towards the listener, and the source will go to away from the source, or the listener will go away from the source or comes towards the source. So that's why we have those things. So if the source is moving towards, so now we'll shorten things. If the source if source is moving towards, is moving towards the listener. So if the source is now moving towards the listener, what will happen? The equation will be like this: FL, frequency of the listener, is equals to, open bracket, frequency velocity plus velocity of the listener over velocity minus velocity of the source, close bracket, times Fs. You see, that's how you write it. So frequency of the listener, it is equals to frequency it is equals to velocity plus velocity of the listener. The reason why I'm now saying plus velocity of the listener, it is because it is now coming to us, to the listener, so it will be positive. Okay, so velocity minus velocity of the source, it will be minus, because it will be moving at that certain point to another point. Okay, so if the source is now moving away from the listener, the equation would be FL is equals to V minus VL over V plus Vs times Fs. So now it is moving away from the listener, it will be minus, and this one it will be continuing in its journey, and it will become plus. Okay, so now let me check some few questions. Okay, here's the question, guys. Just a short question. Okay, the siren of a stationary ambulance emits a note of frequency. Okay, before I start here, let me just do an example of a maybe wavelength. So let's just say my another question that I have, let's just say they are saying a hooter on a stationary train emits a sound with a frequency of 520 hertz as detected by a person standing on the platform. Assume that the speed of the sound is 340 meters per second in still air. So calculate the wavelength of the sound detected. Okay, so they want the wavelength, so we just say it's V. Wait, we are gonna use the wave equation. So V is equals to F lambda. Okay, and then we continue. So it's gonna be, now before you calculate, you check, you say V, you say F, and you say lambda. So what do I have? Do I have the velocity as I was given, which is 340? Do I have the frequency? Yes, I was given, which is 520. Do I have the lambda? No. This is what they want. Okay, so now we substitute. 340 is equals to 520 times lambda, so it's 520 lambda 340, then we divide both sides by 520, then my lambda, it is equals to 0, yo guys, let me calculate. So which is 0.65 meters. This is very important, guys. If you leave your units, then it is the same as saying your answer is wrong. Okay, so now since we did the wavelength, now let's do this one. The siren of a stationary object, the siren of a stationary ambulance emits a note of frequency 1130 Hz. When the ambulance moves at a constant speed, a stationary observer detects a frequency that is 70 Hz higher than that emitted by the siren. Okay, so now they say calculate the speed at which the ambulance is traveling. Take the speed of the sound in the air as 343 meters per second. Okay, so Lana, be careful. They want the speed of the ambulance. So what is the ambulance? The ambulance there is our source, and I said the velocity is the what? The speed. So which means we're gonna have to use the Doppler equation. So let's check. FL is equals to, open bracket, V. Okay, before I continue, do we know what the ambulance is going towards or away from the observer? Do we know? Let's go back to our question. The siren of a stationary object emits a note of frequency 1130 Hz. When the ambulance moves at a constant speed, a stationary observer detects a frequency that is 70 hertz higher. So this higher means ukuthi it was higher. So means ukuthi the ambulance is now going towards him. So it's going to be velocity plus velocity of the listener over velocity minus velocity of the source times velocity of the frequency of the source. So you must be careful there. Sometimes they won't tell you, sometimes you just have to get it for on yourself. So what do you have to do? FL V is the 343 I was given. Then my VL VS FS. Let's continue. So what is the frequency of the listener? Do we have it? Okay, they said it was 70 hertz higher than that emitted by the siren, which means for this one of the for the frequency of the listener, you have to say 1130 the frequency of the ambulance plus 70. So 1130 plus 70 is 1200. And then velocity of the listener, they said a stationary observer, so which means it is 0. And then the velocity of the source, what is the velocity of the source? It is the what we want. The frequency of the source, it is 1130 hertz. Okay, so now let's substitute. So there we have 1200 is equals to open bracket 343 plus 0 over 343 minus Vs times 1130. So I want to get rid of this 1130. What must I do? Divide both sides by 1130. You have to be fast and smart. Okay, so this side I'm left with 343 over 343 minus Vs or close bracket. This side I'm left with 1200 over 1130. Okay, so let's continue. I'll just continue here on my paper. Hey guys, that tripod is not there yet, so let's go to our calculator. 1200 divided by 1130, it is 1,06. so this is Doppler effect. So you just have to write the four decimal place 1,0619. okay, 195, because here I have 194 and 6, so I'll take this one and simplify. So it's equals to 343 over 343 minus Vs. Okay, so I'll cross multiply. So 343 is equals to, what is that number times 340? I get 361 comma 06195 minus 1,06195 Vs. So this is maths, guys. So since this is negative, I'll take it to the other side. So 1,06195 is equals to 361,06195 minus 343. Then let's check minus 343. Let me calculate kahle. Oh guys, check, I made a mistake there. So it's supposed to be 364. I'm used to 3 4, but it's fine. So minus 343 is 21 comma 25. So 1,06195 Vs, and then divide both sides by 1,06195 1,06195. Then my Vs, the velocity of the listener, will be equals to 20,008. When I simplify it, it's gonna be 20,01 meters. So it's gonna be 20,01 meters per second. Okay, so thank you guys. I'm sorry for the mess. No, thanks. Continue subscribing and sharing my videos. I hope you enjoyed this video.